Well, hey there, kiddos. Here is your video all about intercepts. Before we get into finding intercepts, we have to know what intercepts are. So there are definitions. You have two different kinds of intercepts. You have an x-intercept, and you have a y-intercept. An x-intercept is the point where a graph crosses the x-axis. So if I have graphed a line or a function of some sort onto my graph, it's the point where the graph crosses the x-axis. That means the y-intercept is the point where it crosses the y-axis. So there are your definitions. I'm going to move on. If you haven't gotten those written down yet, go ahead and pause so you can copy them down, and then you can come right back to the video. So since I know that the intercepts are where the graph crosses the x-axis and the y-axis, to find them, all I have to do is look at a graph and see where they are. Something else you need to know, sorry, I'm going back to the definitions. X-intercepts are also sometimes called zeros. So if you were asked to find the zero of a function, it's the same thing as being asked to find the x-intercept. So, number one here, I've got this pretty little graph. I want to find the x-intercept, the y-intercept, and then the slope. So the x-intercept is where it crosses the x-axis. It's this point right here, which is at 1, 2, 3, comma, 0. That's why it's called a zero, because the y equals 0 at that point. And then the y-intercept is right here at the y-axis, and it looks like it's at 1, 2, 3, so it's at 0, comma, 3. So if I wanted to find the slope of that line, I'd use my two pretty points and I would count my rise over my run, which happens to be -3/3, which is the same thing as -1. So I'm going to skip all the way down to number 3. I just felt like this was a more important graph than number 2. So number 3, you are given the picture, but it never crosses the x-axis or the y-axis. But you have to find the x and the y-intercept. So the first thing we're going to do is find the slope of this line. So we're going to count our rise over our run, and it looks like it went up 1, 2, 3, and then it went up over 1, 2, 3, 4. So my slope is 3/4. So I'm going to continue with that. So I'm going to start at this end point right here at the top, and I'm going to count up 3/4, and I'm going to keep doing that and making points until my line extends past the x and the y-axis. So I'm going to go up 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. So then I could extend my line. That's a really poorly drawn straight line. But now I can see, here's my y-intercept and here's my x-intercept. Well, it looks like my x-intercept is at 1, 2, 3, 4, 0. And my y-intercept is down here at 0, -3. So those are my x and y-intercepts. It's real easy to find from a graph. Just look and see where does it cross the x-axis and the y-axis. And if you can't tell, use your slope to figure it out. So now we have some tables. You're being given a table, and I have to find the x-intercept and the y-intercept. There's a couple of ways to do this. Way number 1 is to find the slope from the table, which you know how to do, and then plot some points and use those points to find your x and your y-intercept. Or, hopefully, they're nice and then give it to you in the table. If you will think about what that meant, and if you will look at our points for 1 and 2 here, the x-intercept for both problems, when I did the x-intercept for 1 and for 3, the y value was 0 for both of them. That's because when you're on the x-axis, the y value has no... it is 0 because you didn't go up or down. And then in the y-intercept, it's just the opposite. The x value is 0 because if you're sitting at a point on the y-axis, you didn't go right or left. So x-intercept, the y always equals 0, and at the y-intercept, the x equals 0. So if you look at your table, if I look right here, I want to find my x-intercept first. So I'm going to look in the table for a place where y equals 0, and I see that that is right here. So this is my x-intercept. So my x-intercept is at -3 and 0. And then to find my y-intercept, I'm looking for a place where x equals 0, which is right here. And so my y-intercept is at 0, 5. Now I'm going to use 2 points then to find my slope. So my change from here to here is plus 5. And my change from here to here is plus 3. So my slope, remember, is change in y over change in x. So it's 5 over 3. So this next one, if you will look when they give you the table, they have left the y-intercept and the x-intercept blank. I don't know what values go here, but I do know what my slope is. So there's 2 ways to approach this. I'm going to show you the easier one. The first way to approach this, I'm going to tell you about it, but we're not going to do it, is to use this slope to help you fill in the table. The problem is your table does not always follow the increments of your slope. And so the other way to do this is to plot your points. You can always, without doubt, pull out a sheet of graph paper, make an XY coordinate, and plot points. So that's what we're going to do. We're going to start with the first one. I have negative 9, 5. So negative 9, negative 5, 1, 2, 3, 4 is down here. Then I have negative 3, negative 3. And then I know it's 0 something and something 0. We'll deal with that. And then I have 9, 1. So there are my points. Now I know my slope is 2 over 3. That means that from one point to the next, I need to go up 2 and over 3. So if I start at this point way over to the left and I count up 2 and over 3, well, I've run into a problem already. Because that point doesn't make sense if that's the case. 1 minute, pause. Okay, so we need to make a change because as I have just discovered while I was looking at this problem, the slope of this should be 1/3, not 2/3. That is going to be a mistype. So change it to 1/3, then we're going to use it. So we're going to use our slope so that we can get from one point to the next. So we're going to go up 1 and over 1, 2, 3. There's a point. And then I'm going to go up 1 and over 1, 2, 3. Oh, I'm good. Up 1 and over 1, 2, 3. Up 1 and over 3. Up 1 and over 3. And then up 1 and over 3. So now I have this line. I can connect my dots and make a line, and I can see now that it crosses the y-axis here and the x-axis here. So my x-intercept is at 0, negative 2. Sorry, that's my y-intercept. It's at 0, negative 2. And my x-intercept is way over here at 1, 2, 3, 4, 5, 6, 6, comma 0. So that's how you do that. The slope is 1/3, and here's how we could have checked it. Other than when I tried to do it, it didn't work. My points did not line up like they should have. That's how I knew, but you can use your table to find out. My change from negative 5 to negative 3 is going to be a change of 2, and my change from, pardon my ESPN update, my change from here to here is going to be plus 6, and so when I do 2 over 6, that reduces to 1/3. So that's how I knew my slope was 1/3. So that's the deal. So I had my slope, I used it to fill them in, and so my y-intercept is 0, negative 2, my x-intercept is 6, 0. So now let's talk about using an equation. If I want to find intercepts, I'm going to have to use an equation. And so here's what you need to remember. First of all, remember that at the x-intercept, if I want the x-intercept, that means y equals 0. X has a value, y does not. And so when we are using an equation to try and find the x and y intercepts, we do something called the cover-up method, and we do exactly what it sounds like. We cover up the variable we don't want. So if I want the x-intercept, I cover up the y. Because if I were to plug in a 0 for it, it would just make a 0 and it would go away anyway. So we just cover it up. So the x-intercept is the same thing as doing 1/2 x equals negative 4. Well, if I solve this equation by multiplying both sides by 2, I get that x is equal to negative 8. Well, so I know then that my x-intercept is at the point at negative 8, comma 0. Because that's what x equaled. Now, if I want to find my y-intercept, then I cover up the x part, because if I were to plug in a 0 for that, it would disappear. So my y-intercept, I have negative 2y equals negative 4. And when I divide both sides by -2, I get y is equal to 2. So I know then that my y-intercept is at 0, 2. So let's try that cover-up method with the next problem really quick. It's a little bit different, so I'm not just going to say, hey, go do it. Let's talk about what needs to happen. So if I want my x-intercept, I have to cover up the y. But if I do that on this problem, I don't have anything then on the left-hand side of the equation. I mean, like I covered up everything on this side of the equal sign. And so what that means is I have 0 is equal to 3x minus 12. At this time, I do have to put the 0 in. Well, then I'm going to solve this, add 12 to both sides, and then divide by 3. And so you should get that x is equal to 4. So your x-intercept is at 4, 0. Pardon me. And then to do the y-intercept, I'm going to cover up that 3x, and I'm going to solve what is remaining. So now I have negative 4y is equal to negative 12. So when I divide both sides by -4, I get y is equal to 3. So my y-intercept is at 0, 3. So there is finding intercepts from a graph, from a table, and from an equation. X and y-intercepts is just the point where the graph crosses the x or the y-axis, depending on which one you're looking for. And that's what we do. So we'll practice this tomorrow. I will see you guys then. Y'all have a good rest of your day. I hope you're happy now, Thomas.